Dr. McKay, thank you so much for that wonderful introduction. Thank you so much for your hospitality. It's been a great morning, and I've loved my visit here at Florida Tech. I also want to say for all of those who are here that are students, Florida Tech is an amazing institution that provides a lot of talent to NASA and a lot of talent to the contractors that support NASA. And what I've learned here today is we actually have about 500 Florida Tech graduates that are supporting the Kennedy Space Center right here in the local community, which is exactly what this university, Florida Tech, was established to do. And it is living up to that mission that it was set forth to do all those years ago. So congratulations for having such a wonderful institution that helps not just NASA, but our country in so many ways. And thank you so much for having me. I would also like to say, I know there's a representative here from Bill Posey's, Representative Bill Posey, another great friend of mine. I've known him for many years. And I will say very clearly, working side by side with him in the House of Representatives, he loves this area. He's looking out for your best interest, and I've seen him work real time, making sure, quite frankly, the Kennedy Space Center has what the Kennedy Space Center needs. I've seen it over and over again, so I'm thrilled to be here in his district, and I look forward to seeing him again in the near future. So it's a big day today. We're going to make an announcement. Before we make the announcement, we're going to in fact announce the contractor that won an element of what we call the Gateway. The Gateway, of course, is a small space station that we will put in orbit around the moon. Think of it as a reusable command and service module that will be in orbit around the moon for 15 years. And the first element is the power and propulsion element. And we're going to make an announcement today who the contractor is going to be that's going to build the power and propulsion element of the Gateway. Now, before I do that, we're going to go through this PowerPoint presentation. So you guys can all just sit on the edge of your chairs. I loved how you laugh. It means you're listening to me. So we're going to go through this PowerPoint presentation. I'll go through the architecture a little bit, and then we'll get to that moment. But here's the thing that I think is important to note. And I know there's a lot of NASA folks in the room. We are moving very fast. We have a new directive to get the next man and the first woman to the South Pole of the moon in 2024. And that is a big deal for our agency. It's a big deal for our country. So I'm going to back up a little bit. One of the very first things that the President of the United States did, President Trump, as far as space policy goes, he issued what we call Space Policy Directive 1. And he said very clearly, we're going back to the moon. I like to say we're going forward to the moon. Why? Because we're doing it in a way that's never been done before, and all of that is embedded in Space Policy Directive 1. So how are we doing it differently this time? This time when we go to the moon, the key word that the President put in Space Policy Directive 1 is we are going sustainably. In other words, this time when we go to the moon, we're actually going to stay. Does that mean we're going to have a permanent human presence on the surface of the moon starting in the year 2024? No, that's probably not likely. But what it means is we're going to have continual access to any part of the moon anytime we want for a strategic presence. And that means with landers, with robots, with rovers, and of course with humans. And I know from the folks that I've met here at this university that a lot of you will be involved in those activities, and I am thrilled about that. So I think these are very important things to think about. So we're going to the moon, Space Policy Directive 1. We're going sustainably. We're going to go with our commercial partners. And what does that mean necessarily? That means instead of NASA purchasing, owning, and operating the systems as we have done traditionally, in many cases, we are going to be able to buy services from commercial companies that have customers that are not NASA. And we welcome that. We want that. That is good for us, because then we can focus your tax dollars on the things that only NASA can do, where there are not yet commercial opportunities. That's where we want to be. So we're going to go sustainably to the moon. We're going to go with commercial partners. We're going to go with international partners. We are building a coalition of nations for a sustainable return to the moon. And just since this has been announced, we have started to get a lot of traction from our international partners. A lot of you in this room know that on the International Space Station, we currently have 15 countries that are involved in living and working in space now for almost 20 years. People, I should say, 18 plus years, because I know it's being recorded and everything the NASA administrator says gets, taken apart. Mostly by the people in this room, I'm sure. But the important, I know I'm speaking to the aerospace community. So this is, I think, these are important things to remember. We're going to go with international partners. This coalition of nations, we have the first one that got on board just a few short months ago, Canada. And they didn't just get on board. They got on board for a 24-year period of time, which is exactly the kind of commitment that we need for this sustainable lunar architecture. And everybody here is familiar with how important the Canada arm has been, and their robotics capabilities have been for the International Space Station. And those capabilities are going to have tremendous value at the Gateway, which is that small space station in orbit around the moon, that reusable command and service module in orbit around the moon. We're going to use those capabilities to get to the surface, as a matter of fact, and we're going to need eventually, we're going to need their robotics capabilities on the surface of the moon. Now, that's another negotiation for another day, but know this, they are with us. And they're the first ones that have stepped up. But there are other countries that are stepping up, and we're in conversations right now with the European Space Agency, ESA. We're in conversations with all of our partners on the International Space Station, Japan and Russia, another critical partner when it comes to space exploration that a lot of people don't consider. It's important to recognize that since 1975, the United States and Russia have had a collaborative, working relationship to live and work in space. I say since 1975. Again, I've got to be clear. There have been some gaps, but if you go back to the Apollo-Soyuz program, and then you go to the Shuttle-Mir program, and now you go to the International Space Station, this is a very unique channel of communication. When terrestrial geopolitics break down, we are able to continue living and working in space together. That's an important capability that the space community brings to our country and theirs. So we're going to the moon, we're going sustainably, we're going with commercial partners, we're going with international partners, and this is a new policy, we are in fact going to utilize the resources of the moon. What does that mean? What resources are we going to utilize? In 2008 and in 2009, we learned that there are hundreds of millions of tons of water ice at the south pole of the moon. Hundreds of millions of tons. What does that mean? That means there's life support. We're talking about air to breathe. We're talking about water to drink, but even better, we're talking about rocket fuel. Hydrogen and oxygen is the same rocket fuel that powered the Rs-25 engines, the Space Shuttle main engines, the same rocket fuel that will power the engines on the SLS rocket, the biggest, most powerful rocket ever built that will carry our astronauts to the moon. So hydrogen and oxygen available in hundreds of millions of tons on the south pole of the moon. That's an amazing resource opportunity, and it's important for us to get there and figure out how to utilize it. I know this is a space tech conference. That's space technology that we need to develop. How do we get the use of those resources? So we're going to utilize and by the way, there's other resources we can get to later, maybe depending on time. As long as I'm going, that might not be the case. But here's where we're going. It's not just utilization of resources either. The last piece of Space Policy Directive 1, given by the President of the United States, is to take this technology, take the capability that we're building to reduce risk, to prove capability, prove technology, and then as much as possible replicate it at Mars. That's why we're building the Gateway. This is a critical capability for not just a sustainable lunar return, but also an eventual journey to Mars, where we will have access to the surface of Mars as well. So this is all embedded in Space Policy Directive 1. Just a little tasking that we have to get underway, so we're going to need everybody in this room to help us out. But it's also important to remember that we put together a budget request based on those directives. And in that budget request, we decided that we were able to get humans to the surface of the moon in 2028. The president and the vice president saw that and they said, that's not good enough. We need to go faster. So the question is, why do we go faster? And this is an important point. Why would we go faster? Friends, we would be on the moon right now if it wasn't for a certain risk. Everybody is familiar, especially in this room, you are familiar with technical risk, technical challenges. Technical challenges are not the reason we are not currently at the moon. The reason we're not at the moon right now is because of the political risk. We have tried this before. The Space Exploration Initiative of the 1990s. Priorities changed, budgets changed, Congresses changed, administrations changed, and ultimately that goes out the window. Then we had in the early 2000s the Vision for Space Exploration, another effort to return to the moon. It was drawn out, it took too long. Priorities change, budgets change, Congresses change, administrations change, and it gets zeroed out. And now we have another administration that says it's important for strategic presence, it's important for international partnerships, it's important for resources, it's important for science that the United States be on the moon. Therefore, in order to retire the political risk, we're going to go faster. So they said, what does it take to get to the moon within 5 years? They came to NASA. What does it take to get to the moon within 5 years? And so we put together a budget request that we could send to the Hill. We sent it to the administration first and said, here's what we believe it takes to get to the moon within 5 years. We were also very careful because the challenges that we've had in the past politically stem from a couple of things. If you try to fund the lunar exploration program out of the Science Mission Directorate by cannibalizing science to feed human exploration, it creates all kinds of political divides within geographic regions of the country. Maybe certain states then oppose other states. So it becomes a parochial issue. And in fact, it becomes a partisan issue. So we know that that doesn't work. Then the question is, well, could we fund it by maybe de-scoping the International Space Station and the amount of funding going there? Well, if you do that, you're going to make a lot of people in Texas upset. You're going to make a lot of people in Florida upset. You're going to make people in Alabama upset. So no, that doesn't work either. So what we got here, in order to get to the moon in 2024, was a new budget request that included an additional $1.6 billion that doesn't cannibalize any part of NASA. And that is a unique moment in all of the decades that have led up to this moment. We should be on the moon right now, but we're not. What have we learned from history, and how do we apply those lessons to today? That's what we've done. Now, this $1.6 billion is a budget. It's an additional budget request on top of NASA's previous budget request for the year 2020. I want to be clear. I'm not saying we're going to the moon for $1.6 billion. What I am saying is, if you take NASA's budget and you add an additional $1.6 billion, and then of course you look at year 2021 and 2022 and 2023, all of those budgets we're working through right now. But we have an amazing start to come out of the gate and actually get capability going to get us to the surface of the moon in the year 2024. The administration, friends, has been extremely supportive of that. And for that, NASA, I personally am very grateful for all of their strong support. It's also important to note that the Vice President, by direction of the President, at the last National Space Council, by the way, raise your hand if you're in this room and you're familiar with what the National Space Council is. Let's do this the other way. Raise your hand if you're not familiar with what it is, and that's okay. There are folks. Okay. So we have, under the law, the ability for the administration to create what we call the National Space Council. What that means is you take all of the different heads of agencies and the different cabinet secretaries that deal with space, and you put them on one committee, and then they get together and they discuss and they make decisions on how to make sure that America is the preeminent spacefaring nation. And this has existed going back to John F. Kennedy, had Lyndon Baines Johnson, of course, heading the National Space Council. Administrations that came after that took it away. Others brought it back. At one point, George Herbert Walker Bush reestablished it, and then when he left office, it went away. Well, the president brought it back, and he put the vice president as chairman of it. And of course, on this National Space Council sit the Secretary of Defense, the Director of National Intelligence, certainly the Secretary of Commerce, Secretary of Transportation, the NASA Administrator, and others that touch space. We come together and we talk about how each one of us are working on space issues. So in this National Space Council meeting that we had, the Vice President announced that when we go to the moon in 2024, and we very clearly he said, the next man, and this is an important point, the first woman that land on the moon will be Americans. He also said that we're going to land on the moon in 2024, and he said we're going to land on the south pole of the moon, which is where all of that water ice is. But there's a critical thing that he said that I think caught everybody's attention, which is the next man and the first woman. That's a significant difference than the Apollo program that we had in the 1960s and the early 1970s. Why is it different? Because back then, all of our astronauts came from the military. They were all fighter pilots, or not just fighter pilots, test pilots. But the bottom line is there were no opportunities for women. And now for the first time, we're going to send a very diverse astronaut corps to the surface of the moon to inspire the next generation. I have an 11-year-old daughter. My 11-year-old daughter, I want her to be able to see herself as having every bit of the opportunities that I had growing up. And this, I think, is a perception that we need to fix, that every American has an opportunity to go to the moon. Now, not every American is going to go to the moon, and I understand that. But when we see the cadre of folks, the very talented astronaut corps that we currently have, we know this, that we can send people of all backgrounds, race, religion, gender. They are very diverse and very qualified. Which is one of the reasons that when we decided, what are we going to call this particular program, we thought about Apollo. Apollo is an amazing historical achievement. We all remember it, those of us who are alive, and I quite frankly wasn't, but I've read about it in books and seen it on TV. And I'm inspired by what was happened before I was born. But we think about the Apollo program. Here's what's interesting. Apollo had a twin sister. His twin sister, Artemis, happens to be the goddess of the moon. What an amazing 50-year anniversary. 50 years after Apollo, we go back to the moon sustainably with commercial partners, international partners. We utilize the resources of the moon. We prove technology. We want to plan to take it to Mars. We do it with this very diverse and capable astronaut corps to inspire every American to see themselves in that role. And we name it after the twin sister of Apollo, Artemis. We, friends in this room, are the Artemis generation. You are part of the Artemis generation. We need to create a movement for the Artemis generation. 50 years after Apollo, the twin sister of Apollo, Artemis, is going to be the program that takes our astronauts to the moon. We're going to watch a short video here, and then I'll get into the... Please.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed. And with components in production
and more in testing,
This system is capable of being the catalyst for deep space missions
we need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable.
That can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
an orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits
It will balance between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
Did anybody recognize the voice in that video? William Shatner. Captain Kirk himself. So we're going to talk about the Artemis program. We're going to talk about what is the plan. How do we achieve this? We're going to try to put some details into it, and then I'm going to open it up for a few questions. So if we could go to the first slide here. So when we look at this slide, what we're really looking at is a series of missions that takes us from Artemis 1. This is, in fact, the first flight of SLS with an Orion crew capsule that goes around the moon uncrewed. Artemis 1 is an Orion crew capsule that goes around the moon uncrewed. And by the way, it's going to do some significant testing in orbit at the moon as well. When we go to Artemis 2, we're talking about the first humans to the moon in the 21st century. Now, these humans are going to enter orbit around the Earth, and we're going to test all of the metabolic systems, all of the life support systems on the Orion crew capsule in orbit around the Earth. That's the best place to test it. We don't want to test it at the moon. I see some people giving me a thumbs up on that. That's the goal, test it around the Earth. Now, what that means is that when we do launch it to the moon, which we will do on that flight, we want to take it to the moon, we want all of the life support capabilities tested. Then when we take it to the moon, it's going to not have quite as much delta V as it would have had before, but we can still do a free return trajectory. In other words, we can launch it around the moon. We're not going to get into low lunar orbit. We're not going to be able to test necessarily the navigation capabilities and the maneuverability capabilities, but we can do a free return trajectory after testing the life support capabilities of the spacecraft in orbit around the Earth. So Artemis 2, look at the timeline here. This is 2019. I know it's hard to see 2024 over there. We're looking ultimately to be able to launch humans around the moon in about 2022. for the first time since the Apollo program. Now, after that, we've got to start building the gateway. The first element of the gateway is the power and propulsion element. I want to anchor for a second on how important the gateway is. The gateway has solar electric propulsion. It's in what we call a near rectilinear halo orbit, where it is balanced between the Earth's gravity and the Moon's gravity. In that near rectilinear halo orbit, it can use that very, it's small thrust. We're talking about solar electric propulsion, very small thrust, but it can stay in that orbit for very long periods of time. But because it does have that very light thrust, it can also maneuver. It can go to the L1 point, it can go to the L2 point, and it can go between all of these different, very balanced areas between the Earth's gravity and the Moon's gravity and even the Sun's gravity. That's the value of the gateway. It gives us, key point, it gives us more access to more parts of the Moon than ever before. Why is that important? We go back to 1969, 1970, 1971, 1972. 6 Apollo missions that landed on the Moon. 12 people walked on the surface of the Moon. I know Andy Aldrin is here, and of course his dad was one of the heroes of all of us. But they missed something. What did they miss? They missed the fact that there's hundreds of millions of tons of water ice at the South Pole. Their missions were equatorial in nature. We want more access to more parts. And I know in this room, everybody knew that there was water ice there. Oh, I know that. I'm kidding. All of you say that you knew, but nobody really knew. And I kid. Yeah. It's funny, after the water ice was discovered, everyone's like, yeah, we knew it was there. But the reality is we didn't. And of course, if you look at the science books back then, they would say the probability is that it's not there. But it actually is there in hundreds of millions of tons. So we want more access to more parts of the Moon because there's a lot of science that we can do. Why do we go to the Moon? We need this science. We need to learn about this world that is part of the Earth-Moon system. And what the gateway gives us is more access to more parts of the Moon. And that access is not just with landers. Again, it's with robots and rovers and landers and even human landers. Think of it as a command module, a permanent command module in orbit around the Moon that can ultimately control these missions on the surface. So that power and propulsion element with solar electric propulsion, very low delta V, not a lot of power there, but very high specific impulse. It can last a long period of time. The contractor that will be building that element is, drumroll, Maxar. Maxar is going to build that for the United States of America. And I want to be clear about this acquisition process. To go from where we were to where we are right now so fast, this is a monumental achievement for this little agency we call NASA. And this is going to be the example of how we move things going forward. Because if we're going to get the next man and the first woman to the South Pole of the Moon in 2024, we have to have this kind of urgency. We have to move at this level of speed. It is also true that we are procuring that power and propulsion element of the gateway. We are procuring it in a way that we haven't done before. We will have an option to take possession of it after it's on orbit. In other words, we're buying it commercially. They're building it, and then if it all tests well, then we acquire it as a country. So this is a different way of procuring it, and it is a big change, and we need to get used to this kind of change as an agency. And we are. We're making these changes quickly. Now, as you go forward, once we have the power and the propulsion element, then we need a crew vehicle. We need a pressurized vehicle. Sometimes we call it a habitat. But I want to be clear. We are not building the International Space Station around the Moon. In fact, I don't know that we can call it a habitat at all. We call it a utilization module. Think of it as a very, very small habitat that has a purpose. The purpose is to get our humans onto a lander and take them down to the surface of the Moon. That's what it is there for. There have been times in the past when we talked about the Gateway as a very big device that was going to be a big space station for long periods of time. That's not what we're doing by 2024. What we're going to have by 2024 is the power and propulsion element and the utilization module. We call it phase one of Gateway. Now, by the year 2024, this gets us to Artemis 3. By the year 2024, we will have aggregated at the gateway, we will have aggregated potentially three elements of a lander. So by 2024, the gateway will be complete and we will have a lander complete. Now we've got to get there. How do we get there? We launch on the SLS and Orion with the European Service Module. Yes, our international partners are involved in this from day one. So by Artemis 3, we will, no kidding, send our astronauts to the gateway where they will transfer into a landing system and go down to the surface of the moon. We are purchasing that landing system also in a way that's never been done before. We're going to buy it as a service. NASA is not going to purchase, own, and operate the hardware. We're not going to write thousands and thousands of requirements, basically designing it in the requirements process, and then putting out an RFI, getting information back, putting out an RFP, evaluating proposals, and then having industry respond to those, all those proposals with all their different ideas, and then some year down the road make a decision and have a contractor. That's not what we're doing. We're saying, who can we buy the service from? Our goal is to say, we have an astronaut at Gateway. We want to buy a service. Get them to the surface, get her to the surface, and get them back to the Gateway. Who can do that? Because that's what we're buying. We're not owning the hardware, we're buying the service. And that will be on Artemis 3 in the year 2024. In the meantime, you can see the surface of the moon down here. We're going Earth to the moon. The swoosh takes us to the moon. In the meantime, we have these different robotic missions on the south pole of the moon, operated under a new system that we call CLPS, the Commercial Lunar Payload Services. We are testing again our new model of acquisitions. What am I talking about? I'm talking about, we're talking about small payloads, 15 pounds, 20 pounds, to the surface of the moon, science payloads, science instruments, maybe some rover capability, but we're buying this as a service to the surface of the moon as early as next year. These are small payloads to the surface of the moon, bought as a service as early as next year. NASA has the instruments, we're ready to go, and we've identified contractors, 9 of them, that have the ability to get us to the surface of the moon. Eventually, we're going to have larger scale landers, and then humans on the moon for the first time in the 21st century in the year 2024. So that's the plan to get us to the moon. And at the bottom, you can see it's very clear. Lunar South Pole is the target. And of course, why? Because that's where you've got the peaks of eternal light for solar power. And you also have those permanently shadowed areas where the water ice is. That's why we go to the South Pole. Okay, next slide. This is an important slide because it shows how we're going to launch these systems across the top. Artemis 1, Artemis 2, Artemis 3, these are the human launches that take us from the Earth to the moon. And I mentioned Artemis 1 is uncrewed, Artemis 2 is crewed, originally around the Earth. We launch it, free return around the moon. Artemis 3 takes our first crew to the lunar surface, of course, first taking them to Gateway. At the bottom, and by the way, I want to be clear about SLS and Orion. Since I've been the administrator, we have looked at every option to get humans to the surface, to get humans to the Gateway, I should say, as fast as possible. SLS and Orion is the only system that gives us any chance of getting there in 2024. We've looked at everything. We've considered everything. SLS and Orion, that is the system. And once it's developed, we will use it over and over and over again. Okay, at the bottom, commercially provided elements. We talked about the power and the propulsion element. We've got a crew module. That's the habitat, that small habitat. And then we have the landing system. Now, we have here on the landing system, we have a transfer vehicle. Remember that near rectilinear halo orbit that's basically it's in orbit around the moon, kind of balanced between the Earth's gravity and the moon's gravity. The challenge is that's kind of distant from the surface of the moon. In fact, it's very distant from the surface of the moon. It gives us durability, sustainability, 15 years, solar electric propulsion capability, but it's distant from the surface of the moon. So we've got to get down to low lunar orbit first. That's what the transfer vehicle is all about. It gets us from the Gateway down to low lunar orbit. Then, once we're in low lunar, we need a descent module. That puts us on the surface of the moon, and then we need an ascent module that gets us back to Gateway, where our crew can get back into Orion and come home. Now, I've identified 3 elements of the landing system. But what did I say previously? I said that we're buying this as a service. And there are contractors out there who have it in their mind that they could do this with just 2 elements, a descent and an ascent, and skip the transfer. And by doing that, they believe they could save money and help NASA achieve this even faster. I want to be clear. If they can, we're for that. If others have another way of doing it, we're okay with that too. We're going to look at all proposals. We are buying a service. We're not going to write the requirements and tell them specifically how to design their project. We're buying a service. Again, the goal here is speed. 2024 is right around the corner. So these, and I think the other important thing is SLS and Orion, each one of these elements is going to be launched commercially. This brings all of America together. Those of us in this room, we know that there is this tension between traditional space and new space, or traditional space and commercial space. The different launch providers, there's a tension. We cannot achieve this objective if we don't bring everybody together under one umbrella, everybody together under one tent. And the 2024 agenda guarantees that we're using the government-provided capabilities and we're using commercial-provided capabilities. And that is ultimately how we bring not just the country together from a contractor perspective, many of which are in the room. It is also how we bring our country together from a representative perspective. We're talking about some of the parochial interests from the House and the Senate, which I understand all too well because I used to be there myself. So I think that's an important slide right there, bringing everybody together to achieve the end state. All right, the next slide. This kind of shows you 2 segments here. Between now and 2023, we are developing. It's important to recognize we are developing SLS, we're developing Orion, we're developing the European Service Module, we're doing these CLIPS missions, we're doing the power and the propulsion element, and we're doing the habitation module at the Gateway, and at the same time, we're building the landers. You can see there's not a lot of launches here, there's a lot of development. 2024, there's a transition. 2024, we've got 3 commercial launches potentially to get the lander to the Gateway. At the same time, we've got Artemis 3 launching the next man and the first woman to the Gateway for their eventual lunar landing. So that's 2024. And then after that, you can see all of the activities. What we need has been developed. The other important thing to note, and this needs to be said, as much as possible, we want to build reusability into every piece of the architecture. Reusability is key. I know here on the Space Coast, we know how important it is to reuse rockets. We've seen it with SpaceX. We've seen it with Blue Origin, reusing New Shepard. Reusing rockets drives down cost and it increases access. Reusability is a key to the sustainability that we're trying to achieve. So what does that mean? The Gateway is by definition reusable. It will be there for 15 years, a reusable command module. But we also need these landing elements to be reusable as well. Now, not every piece of the landing system is likely to be reusable by the year 2024. But we want to have the opportunity by 2028 to have those landing systems be reusable as well. So we are trading a little bit of reusability potentially for speed to get there in 2024, to accelerate the path and retire the political risk. That's the goal. All right, next slide. So this is the Gateway. I want to make sure that people understand kind of what we're doing here. For 2024, it is a minimum gateway, and that's what's pictured here. It looks like kind of a big space station, but what you're talking about, you see the big solar panels attached to the power and propulsion element. That's the power and propulsion element. Then this is the utilization module. This is Orion approaching the Gateway, and all of this up here is a landing system. But this is the entirety of the gateway. To be clear, we are not building the International Space Station around the moon. I want to emphasize that. That is not our goal here. We as a nation do not want to get bogged down with all of our resources going to the moon. Certainly we want a presence, we want access anytime, anywhere at the moon. But our goal is ultimately to move on to Mars and not get stuck on the surface of the moon. As much as we need to be on the surface of the moon, we don't want to have that be the final destination. That's why it's important to not build the International Space Station around the moon, because then our resources can be used for the missions beyond. So it's a command center, aggregation point for the human lander. It establishes a strategic presence around the moon. It places the United States of America in a leadership role. Now, what do I mean by that? So the gateway, this is a great, think about this. It's open architecture. The way we do docking, the way we do avionics, the way we do communications, the way we do life support, all of these things are going to be available on the internet. So if there's a small country out there that wants to build their own lander and use the gateway to ultimately have their own system to get to the surface of the moon, we welcome that. If there is a private company out there, maybe there's a billionaire that wants to use the gateway to get to the surface of the moon with their own lander, because maybe they believe there's precious metals in a certain part of the moon. Are there precious metals there? I don't know. Nobody else does either, but we ought to find out. That's why we're going. We missed for 39 years. We missed that there was water ice at the South Pole. What else have we missed? We know that there are rare earth metals on the Earth. We also know they're hard to come by because the Earth has a very active rare earth metals, just you guys know this. Rare earth metals are not earth metals. They're asteroid impacts from billions of years ago. But the Earth has this very active geology, and it has a very active hydrosphere, and it has a very active atmosphere. What that means is that those rare earth metals are hard to come by. They're not where they used to be, and when they're discovered, they're in very trace amounts. But the moon does not have an active geology or hydrosphere or atmosphere, which means anything that impacted the moon a billion years ago is today right where it was a billion years ago. So we could find out that there's a market for going to the moon to find platinum group metals or some other kind of precious metal that people might believe are there. And we want to encourage that. In fact, when I was in the House of Representatives, we passed a bill, the Commercial Space Launch Competitiveness Act. Maybe some people in this room helped us with that bill. And that particular bill said that if you invest your own sweat equity, if you invest your own money into going and extracting resources from the moon, you can attach your effort to that resource. In other words, you can own the rights to the resources you extract from the moon. That is in American law, passed by bipartisan House, passed by a bipartisan Senate, and signed by President Obama. And it was a proud day, in my view, in American history. So we want to enable that activity, and that's what we're trying to achieve. We're creating resilience and robustness in the lunar architecture, the key being the word sustainable. And it's a building block for the future, expanded capabilities. You can imagine a day when our partners, our international partners, could be European, could be Japanese, could be pick your country, building their own habitation modules that would attach to Gateway. And we are working with them even right now to achieve that goal. All right, next slide. Now this is the Space Tech Conference. These are all space technologies that we are developing right now in order to achieve these goals. I'll just start at the top. High-performance spaceflight computing, critical capability that we need to develop. Precision landing. I think here at the Space Coast, you guys are familiar. There might be some companies that have figured this one out. Landing on a barge in the middle of the ocean to bring it back. Bringing it back, no kidding, to within a few miles of where it took off and landing it in a precise spot. Precision landing is a critical capability. Solar electric propulsion at the 50 kilowatts and above. That's what we're actually building on Gateway, which, did I mention, Maxar has that contract. This is a critical capability, cryofluid management on the surface. So we talk about the hydrogen and the oxygen on the surface of the moon. We know how to store liquid oxygen in the space environment. Hydrogen is a lot more difficult. We need to figure that out. It boils off. We need to figure out how do we keep keep liquid hydrogen in liquid form in deep space in vacuum and thermal conditions. Lunar dust mitigation, big challenge. Lunar dust is very fine. It gets in equipment. It can do a lot of damage. Service excavation and construction. Using the regolith, no kidding, to create bricks and actually build. One of the challenges on the moon is the radiation of deep space. There is no magnetosphere to protect humans on the surface of the moon. Without a magnetosphere, we got to figure out how do we protect humans. Well, using the regolith, maybe getting under the surface, maybe building something, constructing something, some kind of shelter that would go around a habitat using the resources of the moon. Which brings us here to in situ resource utilization. We need to figure out how to use the resources of the moon to live and work for long periods of time. In this room, everybody knows, Earth and Mars are on the same side of the sun once every 26 months. That means when we go to Mars, we got to be willing to stay. Can't go anywhere. You're going to be there for 26 months, or at least a couple of years. So if that's the case, where's the best place to prove how to live and work on another world? How about a world that's a 3-day journey home rather than a world that's a 9-month journey home? Seems like the moon would be a great place to do that. So that's the reason. That's another reason the moon is so important. It's a proving ground for all of the activities we need to do at Mars. Lunar surface power, critical capability, extreme access. We want to be able to get to all parts of the moon. That means not just using the gateway to get landers to different spots. Once you're on the surface, having rovers, maybe even getting under the surface of the moon. So space technology is critically important for our future long-term stays on the surface of the moon. Next slide. All right, so then remember, 2024 is all about getting there. After we get there in 2024, it's all about sustainability. So let's go to phase 2. And I think I've already pretty much hit all of these points. Collaboration, long-duration human missions, testing the impacts on human performance. Why? Because we're eventually going to go to Mars. Repeatable operations for traveling from the Earth to the gateway, to the surface, with reusable systems. We're building sustainability by the year 2028. Unprecedented science outside of Earth's influence. We talked about that. And it's not just about water ice. It's not just about precious metals. When we talk about science, again, we've got these charged particles that are coming from the sun, and they're impacting the moon all of the time. It's how we have water on the moon right now. So the question is, without an active atmosphere or hydrosphere, we have great data about the origins of our own solar system embedded in the surface of the moon. All we got to do is go get that data. Now, there are a lot of lunar scientists that are very excited about getting to the moon to get that great data so we can understand more about the origins of our solar system. Maintaining a strategic presence in deep space, and then increasing international and commercial partnerships. I think I've hit everything on that slide. All right, let's go to the next one. Okay, that's it. We're going to go to the moon, and we're going to do it sustainably. We're going to do it with commercial partners, international partners. We're going to utilize the resources of the moon. We're going to take what we learn, retire the risk, prove the technology, and go to Mars. That's the goal, and this is getting us started. I'm open to questions.
Hi, Jim. Great talk. John Delacosta from the University of Florida. You said that we were accelerating the Artemis program because, and it would, I don't know if you said eliminate exactly, but it would eliminate the political risk.
It would reduce it.
It would reduce it.
Yeah.
How big of a risk do you think the 2020 election is going to be on the Artemis program? And do you think, how big do you think the effect will be on the program if there is an administration change? Thank you.
So this has been the problem in the past, and I'm not going to make any predictions about elections. That's not my job. But what I will tell you is that if we do this right, this is not partisan, nor is it political. One of the things that I enjoyed very much being on the House Science Committee, which oversees NASA, the Space Subcommittee specifically oversees NASA, is that it was very apolitical. It was very bipartisan. There are little areas where we might have disagreements, but it was very bipartisan. And again, I really believe, since this is the Artemis generation, and it is time for us to have our own capability. I was not alive when we landed on the moon. I'm the first NASA administrator that was not alive. This is not political. It's not partisan. It is our time. This is the Artemis generation. We need to go back. We need to go back with the diverse and capable astronaut corps that we have. And I will tell you, I've seen strong bipartisan support in both the House and the Senate. Now, they might not like how it's paid for, and they might not like the budget request and this kind of thing, but they are all seemingly, this is the question I get from both sides of the aisle. Do you have what you need? Is it enough? And the answer is, well, if you want to give me more, I'll take it. Not true. I stand by the budget request. But my point is that there is bipartisan support. So I will also say we don't just see it on the science committee, we see it internationally. There's all kinds of geopolitical divides these days, especially when you consider Russia. I don't know if you've noticed, but there's this challenge there. But yet we're still able to maintain the International Space Station. Our astronauts are working side by side with theirs. In mission control, we've got their folks working side by side with ours. So it transcends geopolitics. It transcends partisan politics. I really think that if we roll it out right and people understand why we're doing this, the inspirational elements, the this is our moment kind of elements, if we do it right, with your help and others in the room, I don't think that this will be at risk, whether it's 2024, 2028, 2032. I think we're going to be in good shape.
Hi, my name is Luis. I'm an aerospace engineering student here at FIT.
Oh, great.
The question I have to you, sir, is about the Resource Prospector rover.
Yeah.
That we understand that we want to investigate the craters to find water.
Yes.
But we understand that the most important mission that I see, the Resource Prospector that was canceled, it is a very important step.
Yes.
Does NASA have any plans to bring that mission back to before we send all the mankind and womankind there?
Yeah.
Are we sending rovers before to confirm the data?
Absolutely, and it's not. So the answer is yes. The Resource Prospector mission. There were on the day of my not confirmation, but the day I got sworn into this job a year and some months ago. There was a lot of hoopla about us canceling this project. All of those instruments still exist, and we didn't just cancel the project, we put it on steroids. When we talk about, if we can go back to the CLIPS slide, the slide that has the swoosh across the top, we talk about these missions to the surface of the moon. You can see right here, large-scale cargo lander. Certainly if we can do that, we can actually put a rover on the surface of the moon. Talking to our international partners, a lot of them have a rover in development. So the answer is yes. We are going to have a lot of missions to the surface of the moon long before our first astronauts get there. Why? We want to make sure when our first woman steps out of the capsule and onto the surface of the moon, she has very meaningful scientific work to do. I also want to be clear, some people have said, well, it's just a stunt, they're just going to walk around and get, no. This is sustainable development, and there's going to be meaningful work on the surface of the moon, and we're very excited about it. But between now and then, with CLIPS, we're going to have a lot of missions. I also want to be clear when it comes to, when I say CLIPS, Commercial Lunar Payload Services. We're buying services to get to the surface of the moon with small scientific instruments, like maybe a small rover. When we do this, and this is going to take maybe some effort for a lot of people to understand across this country, there's risk. When we talk about CLIPS, these small landers going to the surface of the moon, think of this as venture capital. So the cost is low, the risk is high, but the payoff, if one of the 9 providers can succeed, the payoff is massive. That's what we're trying to achieve. We're trying to. One of the things the Vice President said at the last National Space Council that I took away as an important thing, he said, fail smartly. In other words, he understands that there will be failure. But what we have to do is we have to fail smartly. Again, low cost, higher risk, but if it works, higher reward. Learn from each one of those and build them into future systems, and that's what we want to do with bigger landers. But yes, we will be back on the moon long before 2024 with rovers.
So with Vasu from University of Central Florida, very impressive talk.
By the way, University of Central Florida, 2017 national champions. the one and only undefeated national champion in the year 2017. Congratulations.
Thank you. First of all, very impressive talk. It's like one of the most inspiring talks I've ever listened to. As a faculty, I always wonder, what is your vision, how universities can play in the future of, NASA's mission, and also how do I inspire students to be part of this?
Wonderful, wonderful question. Thank you for asking it. We want universities all across this country to be involved. Our goal is to inspire your students. That's what NASA does. We are about inspiration. Again, if you talk to the folks who work at NASA and all of our contractors who are of age, they remember exactly where they were when Neil Armstrong and Buzz Aldrin landed on the surface of the moon. They remember it, and it changed their lives, and because of that, they went into this industry. We need to recreate that for this generation. That's what Artemis is all about. As far as universities getting involved, it's the low technology readiness level capabilities that universities bring when it comes to early development of technologies and capabilities. And as we grow, when I say TRL, do you know what that is? Technology readiness. So like the things that are way early in the development cycle that have to be invented, as a matter of fact, universities are very good with that activity. Universities are also really good with activities that include research from the data that we collect. We want to make sure when we are sensing the moon in every part of the electromagnetic spectrum, when we're bringing samples back from the moon, when we're bringing, in fact, potentially water ice back from the moon, we want to make sure that universities can share in that and actually have access to it and do research with it and have your students get engaged with it, get engaged with the research on those activities. So we need to get universities engaged. In fact, universities have been engaged, but we need to make it broader. We need every person who wants to be involved in participating in this, whether it's even online, taking the data and manipulating the data and coming up with new ideas, or some universities are actually building hardware. We have universities right now that are in fact putting together missions to the asteroid belt on the other side of Mars. They're going to go out to Psyche, which is a huge metal sphere, perfectly round metal sphere in the asteroid belt that if you brought it to Earth, it would be worth trillions of dollars. What is it? Is it a planetary core? We don't know, but we need to go find out. And so that's being led by a university. And there are other missions like that that are being led by universities that I think engage students early in their careers, get them actively involved. And we need to keep doing those kind of activities, and we will. I just want to say what an honor it is to be here at Florida Tech. It's been inspirational for me to spend time. And of course, President McKay, thank you for all of your time and effort putting this together, and your team putting this together. Great conference here, and look forward to being back in the future. So thank you so much. Thank you, sir.
What a tremendous presentation by the administrator.